Hello, welcome to this video. This is 9-5 and we are talking inverse of exponential functions, which you guys already know is logarithms, right? So I'm going to show you how to go from an exponential function to its inverse, which is a logarithmic function. All right. Here, the inverse of a function or relation is the set ordered pairs b comma a obtained by interchanging or switching the coordinates of each point a, b in the original relation or function, which you guys know, right? Switch x and y, that's how we find our inverse. For inverse functions, if f of x is the original function, then f inverse of x is the inverse function, right? And then just a little note about how we pronounce that, right? F inverse of x is read just as that, right? We don't say f to the power of -1, okay? Because x and y coordinates are interchanged to create an inverse function, the domain and the range essentially switch, and that makes sense. So here is a graph of a function or relation and its inverse, right? And there'll always be reflections over the line y equals x. So, pardon me. If we were to switch out a and b, these are the images you would obtain. Now, when will our functions, our inverse functions, be equal to each other? Well, that will always occur on the line y equals x, which is here and here. Now, you might ask yourself, why don't these two functions intersect? Well, notice that our function f of x never intersects the line y equals x, so that makes sense. Okay, so here is the procedure that we're going to follow today when we are solving for the inverse of certain functions. The steps are, 1, change the function notation to y. So we'll have to switch out of f of x, just change it to y. Step 2, switch x and y, right? That's how we find our inverse. Step 3, use algebra to solve for the y variable. So here are kind of some steps. Our first goal will be to isolate a power expression, and then I'll show you what that looks like in a moment. Then we'll write it in logarithmic form, and then C will isolate or solve for the y variable. Make sure we're solving for an inverse function, so we have to go back to function notation. That's very important. Okay, so here is our first example. We're asked to find the inverse of each function. Okay, so I'm going to take my function and I'm going to write it as a multivariable equation. So y is equal to e to the power of x plus 3. So I just switched out of function notation, right? That's step 1. Step 2, we're going to go ahead and we're going to switch x and y. So x is equal to e to the power of y plus 3. Okay, here comes kind of the tricky part. So part 3, we want to solve for y. I want to isolate y. Now, I don't have inverse operation tools at my hand to bring down the power yet. We'll talk about that next unit. But I can switch from an exponential function to a logarithmic function, which is exactly what we're going to do. And part 3a, it said isolate the power expression. This is a power expression. It's a base with a power. Base with a power. That is a power expression. And I would even write that down. Base with a power, right? That is your power expression. Okay, so that's how you know when we'll switch to logarithmic form. Okay, so I want to switch, and that's going to be log base e, which I'll adjust that in a moment. Okay, inputs and outputs switch. So I have log base e of x is equal to y plus 3. Now I'm just going to go ahead and switch this, right? Log base e, that's known as the natural log of x is equal to y plus 3. And then I want to go ahead and solve for y by subtracting 3 on each side. Okay, so we have the natural log of x minus 3 is equal to y. Notice how I didn't include that -3 inside the argument. It doesn't go into the logarithmic function. Okay, so just note, right, that I have the natural log of x. That's it. Then I subtract 3 from there. It's very, very different than taking the natural log of x minus 3. Different things. Okay, so here's our inverse function, and I want to go back to function notation. This function up here was called f of x, so f inverse of x is equal to the natural log of x minus 3. Okay, and there is our inverse function. Example 2, here g of x is equal to 2 times 10 to the power of x minus 5. So, okay, I'll go ahead and switch to y from function notation. then I'll switch x and y. X is equal to 2 times 10 to the power of y minus 5. Okay, and people often ask, can I just go straight to x equals 2 times 10 to the power of y minus 5? Can I just do that in like one step? Yes, sure you can, but be careful not to make mistakes. So now I want to go ahead, I want to isolate my power expression. Notice I have a 2 on the other side. So what I'm going to do, I'll use inverse operations. I'll divide each side by 2. And we have x over 2, or 1/2 x, is equal to 10 to the power of y minus 5. Now I have my power expression isolated, right? A base with a power. That's a power expression. So now I can go ahead and switch to logarithmic form. Okay, so I want to take log of this base, so log base 10 of x over 2, right? Inputs and outputs switch, is equal to y minus 5. And I'm going to put parentheses over this x plus 2 just so you don't make that mistake of moving that 5 in there with them. Okay, now log base 10, this is kind of trivial to write log base 10, right? This is just known as the common log. So I'll say log of x over 2, or 1/2 x, is equal to y, and right in this step we're going to add 5 to each side. Add 5. Okay, so actually going to include that. Plus 5 is equal to y. Okay, so our inverse function, g inverse of x, is equal to log of x over 2, or 1/2 x, plus 5. And there is your inverse function. Pretty straightforward, right? Okay, I have one more to show you. Okay, so here is the next example. Okay, and these are just as simple as the ones before. So y is equal to e to the power of 3x plus 5. Switch x and y. Okay, and I want to isolate my power expression. So subtract 5. X minus 5 is equal to e to the power of 3y. Okay, now my power expression is isolated, right? That is this. This is the power expression, a base with a power. And I'm going to go ahead and rewrite it in logarithmic form. So base e, that's the natural log of inputs and outputs switch. So natural log of x minus 5 is equal to 3y. Okay, and now I want to isolate y. So I'll divide both sides by 3. Okay, and we get 1/3 natural log of x minus 5 is equal to y, but I know this is an inverse function, so I'll use inverse function notation. So this is k inverse of x. Okay, and you're done. That's it. All right, so I have some practice problems for you. I want you to go ahead, try these. Please pause the video and try this example. Okay, so hopefully you got this. All right, here's practice number 2. And hopefully you got this. Okay, and here's the third practice problem. Please pause the video. And hopefully you got this. All right, some people often ask me to, can we, instead of writing 1/14 natural log of x plus 20, can I just put it, the natural log of x plus 20 over 14? And yes, you can. Just again, make sure that you know that your argument, right, does not include the 14, right? That the whole natural log of x plus 20 is divided by 14, not natural log of x plus 20 over 14. That would not be correct. Okay, so I have one last example to show you, and this one just has a lot of kind of bells and whistles attached to it, a lot of things going on. So the main idea, right, so I'll switch to y and then switch x and y. Okay, And now I want to isolate my power expression. So where's the power expression? Well, that's 2 to this power. So I have to get rid of everything else. Now, if you forget what to undo first or what to divide, remember that when you're always undoing stuff, you always do your order of operations backwards. So we'll always undo addition and subtraction. So I'll add 3 to both sides. So we get x plus 3 is equal to 7 times 2 to the power. Oh, that's 5y plus 8. Okay, now I want to divide both sides by 7. And we get x plus 3 over 7 is equal to 2 to the power. Okay, and now I have my power expression isolated. So now I can go ahead and switch to logarithmic form. So log base 2 of x plus 3 divided by 7 is equal to 5y plus 8. Okay, so now we have to go ahead and isolate y. So again, we'll use our order of operations in reverse order. So subtract 8 on both sides. Okay, and we get log base 2 of x plus 3 over 7 minus 8. Notice how I'm not including that 8 inside the logarithm, right? That's because we did it after, is equal to 5y. And then I'll go ahead and we'll divide both sides by 5, and that will be it. Divide all of this by 5. Again, you can write it like that. That's fine, but I'm going to go ahead and write it as 1/5 of log base 2 of x plus 3 over 7. Okay, and I have to distribute this 5, right? This term's being divided by 5, and the 8 is also being divided by 5. So minus 8/5. And there is your inverse. Okay? All right, that's about as complicated as it gets, identifying inverses. So here's a practice problem. Again, please pause the video. Please try this one, and I'll post the solutions. Okay, so hopefully you've tried this. Here is the solution. Okay, and that is it. That is finding the inverse of exponential functions, which happens to be logarithmic functions. All right, catch you next time. Peace.